Всем привет! Мы в айтишном поиске. Сегодня я покажу, как работать с Prompt.com, отличным бесплатным сервисом по прохождению пробных собеседований. Итак, в личном кабинете нажимаем на Start Practice. На самом деле это только планирование, а не моментальное начало. Интервью бывают на разные темы. Самые популярные — это System Design и, конечно, структуры данных и алгоритмы. Выбираем. Есть вариант платного интервью с экспертом из Фанг. Думаю, это основной способ монетизации для данного сервиса. Но мы, конечно, выбираем бесплатный вариант интервью с другими такими же пользователями, как мы. Выбираем подходящий слот в расписании. Некоторые слоты помечены как более удачные, в том плане, что в них записывается больше людей. Теоретически вам может не достаться пары для собеседования, но у меня за десяток раз такого ни разу не случалось. Итак, запись подтверждена, теперь остается только прийти на платформу в назначенное время с рабочей веб-камерой и микрофоном.
3 days later.
В этом видео я общаюсь по-английски. Есть субтитры на русском и английском, а также мой закадровый голос с примечаниями, вот как сейчас. В целях приватности я не показываю изображение с веб-камеры моего собеседника, однако он дал свое согласие на публикацию интервью.
Hello,
Hello,
I'm Dennis.
how are you doing? Hey, my name is Savan.
Nice to meet you.
Okay, I think you're the interviewer first, so we can get started. I'll
Right, yeah,
read
please.
the question and
Mhm.
yeah, if I have any questions, I'll ask you.
Мне выпало быть интервьюером первым. Мой собеседник предпочитает изучать задачу молча. А зря. Первую половину видео он решает задачу с упрощенным паттерн матчинг. Вторая половина видео — мое решение задачи обхода бинарного дерева.
Okay, so yeah, so as I understand, we just need to check the regex for just these two variables like one dot and star.
Right?
One question is, yeah, we need to also support dot star as well, right? So which is like
Correct.
any characters.
Yeah, it's
Yeah.
combination
Because
is.
in the examples it's not clear, but yeah, okay.
Mhm.
So yeah, let me think through the solution. The,
You can talk, describe your thoughts.
yes. So so my thought is like we should go with recursion approach here, where if we find a dot, right, in our string, we'll single character star. I think it's similar to bytecode. So yeah.
Yeah, I think recursion is a
We
good
need to
approach
check.
here. Recursion.
Yeah.
Mhm.
So approach is I know it's recursion, but what would be the base condition I'm checking? Like what's the condition of like what are the levels of recursion? One is like if yeah, for dot it's simple, like we match with any character and anytime we find it's not equal, we return false, right? That's one. But second, I'm matching with like number of sequence, like where we use star. Right?
Mhm.
So when we get a star, we check what was the previous character. If it's anything else than a dot, then we just go till we don't find any of the same character. Okay. And for each one, we check either we consider it or not consider it. So every time we do a recursion, we split the function. Like once we consider it in our current, if we consider it, does it passes the test. If it doesn't consider, it doesn't pass the test, right? But yeah, I think that we can do.
Okay, let's try. Let's.
Yeah. So here's my recursion function where we return boolean. Boolean is match a new function where we have index integer I, where we are at index of the string pattern and dj, where we are in the pattern.
Mm-hmm.
This match.
Okay.
If the condition that's if pattern dot at j not equals dot and then and not equals then it should be an exact match. So if I equals to caret a always return this match where we go I plus 1 and g plus 1. Okay. That is this. If character is equal to character equals to dot.
Mm-hmm.
You don't care, it's the same thing. You go to the next character.
Okay.
And now else. Now this is the fun part. Okay. So we don't care because it can match any character. Go to the next. Now this is good. Okay.
Mm-hmm.
So yes, yeah. We are going to assume that star, that's a valid string. We are going to assume that the pattern will be valid, so that star cannot be the first character anyway, right? In our pattern. So previous class is equal to pattern dot yep. Okay.
Okay.
Now this is a interesting where or consider I'm just checking the brute force for now. Not sure like what's the I is equal to this is already I got equal to I k less than fixed equal to 0 then minus I e plus plus a.
What will you check in the for loop?
Yeah. So what we are going to check is we are going to just increment the I, keeping the j as same, right? No.
Increment the I.
Increment the I. So either we can skip few characters and check, right? So here we can skip characters. If it's a star, the previous character is a dot, you can skip any number of characters you want. So we can skip till end of the string, right? That's what I'm checking. There's also a case where we want to go till the same character exists, right? I think it's not a...
Yeah, maybe it's better to think without for loop, because really can be like
that complex here. So, what if previous character is A, if this star, this is A, it's already a match. We can go either we can consider. So I was just checking one of the keys. Like let's say we have A as a string and the pattern is A star.
Yeah, good case.
Now, yeah. So at first it will like match. It will go to the next. We get star, right? So now we can consider current is A. Oh, it is. We can skip it, right? Every time. Yeah. So return we can actually return this. We can consider return is match, right? We can either see that. If it is current char.
Yeah, there are like two cases, right?
Yeah. So if is like so previous char equals the x dot at I or previous char equals not anything, right? So if this is the case, then we can okay. If this is the case, then we can return is match of same thing, but we are just incrementing I. We are keeping the J same, or we skip it, right? We go next. Right? We don't consider it as current character. And if it is not, then we just skip it. Current is not equal, we just skip it. Yep. I'm just checking for the condition there. Yeah, so I'm just try running A star for first A. Okay, now we need to check for the, so here written false. Okay, now what's the, when will this end, right?
Mm-hmm.
If, oh, I think that end condition should be at the start.
Yeah.
Okay. If I is equals x dot length, right, and then j equals length, right? If we reach where we are outside and both are right, then we return true.
Well, yeah. Yeah.
And else if any of them is true, like reach the end of one but not the other,
Mm-hmm.
then return false, right? Yeah. So that's the base case here, and we are still in the game if both of them are in the pattern, right?
Okay.
So I think that's it. Let me just try run. So for, let's say A, we go A, we find it's not a special character. So we increment it's equals, so we increment, we go star, we get the previous character which is A. Current characters for the previous character is match the inlet high and keep G as it is.
I don't really get this on line 30. Why? Yeah, you have two
Yeah,
calls. I think I missed the idea.
Okay, so so when we are at considering for star, right? So there might be two cases when we are considering star. One case is like we want to consider the current element in the star, okay? For example, AAA, right?
Mhm.
So now the first A is direct match, but for the other A's, right? But it is matched with a star. Okay? Well, what if our pattern is also A, right? So that star doesn't make any, and that also is a true pattern, right? So we either consider the current element for a star, or we don't consider the current element for a star, right?
I see then. Oh, okay. So you check if you can skip the star and check the rest of A's in the pattern. Well, yeah, that's okay.
So first if it is we check for like it's a star, and then we check if we don't consider it for a star, right?
Mm-hmm.
But I'm just trying. You are at I equal to 2 and j equal to 2. J equal to I equal to 1, j equal to 1. Pointers. if it was a star, it's considered. Then I think this condition needs an or here or g equals to this one. And G
Yeah, very good.
It can be two things at the end. Yeah.
Right.
Okay, I think now I'm good here.
We can
I'm
run
just checking for
some code.
any compilation error. I'm just checking. I think there's some confirmation.
There are
This editor.
few like errors like pattern in line 13.
Yes. I'm checking.
Previous char, it's some lowercase, but in some case it's and semicolon and line 13.
Okay. It's fine. So we'll run the test. No? Oh, we need to make it static.
Right. Two equals, yeah, signs instead of one in 23.
I need to work on this because I would get to run this in real interview. Okay. Symbol at line 13. It's
Length, yeah, also need brackets.
test case.
Okay. Test cases already, yeah. Yeah, valid. Case number 4. Right.
Oh, okay. I found that we also need to check if A can be considered times. Okay, now I can change it a bit. For that, if so what we can do here is we directly skip the star if next character is star, right? And if G is less than minus 1 and pattern of G plus 1 equals R, then we go to the star directly instead of this.
Look,
Text, but we go to the star.
are you looking at the test case number 4, right?
Yeah.
Because you see, I think that case number 4 will end quickly on line like 16, because it compares, so text is empty, so I equals to 0, and it will quickly return on line 16.
Okay. Now I need to figure out what would be the input. Is equal to text dot length. The text dot length is 0.
So maybe you could check, like in line 13, that j equals to pattern length like -2, because star is always like has preceding character.
Mm-hmm. Correct. Yeah. Condition is we didn't reach. Equal pattern length or at correct G.
So what if you like try to change this -1 to -2?
So J is equal to this. Then equal to -2, equal to -1 or 1.
Yeah, something like that.
We are at second to last character and still, okay, because we had considered that character will always match. This will work.
And maybe you don't need this if condition at line 18. Still like shows something.
But that condition is there to skip the character, right? So basically, if we are at A and we are the pattern is A star, right? So we want to execute the star. We don't. If the next character is a star, then let's just evaluate for star. Don't evaluate the current pattern. Get current A. That was for that. Star C. Seventh one.
Okay, so there is just one case to fix.
B star where a character is not even present in the checking here. So or where not a view character, we skip it directly. We skip. We don't need to skip the pattern. We don't need to skip the index. Correct. We don't need to skip the character. We need to skip the pattern. So. Yep.
Okay, yeah.
Okay. Okay. I think we are halfway there. Do you want to switch or do you have any follow-up questions here?
Maybe let's spend some time on like complexity of your solution, time and space complexity.
Yeah. So, n complexity is number of is 2. I think n raised to n square, right? So n raised to number of stars. So n into number of stars we have in the number of stars is m, then n into m. So that's the time complexity. Because for every star we are possibly looking over all the characters.
Mm-hmm.
So m into number of stars. That's the complexity. And space, so we are and same like so number of iterations. So stack size will be n. Maximum stack size will be n.
You know, the actual answer says that it's like exponential complexity in both time and space, because
Space.
like
Okay.
exponential, yeah, because we can like do the recursive calls on like quite deep for
Yeah. So for every star we are splitting it and yeah, correct. So 2 raised to number of stars we have. Right, that would be like n into 2 raised to number of stars.
yeah, cases like that would be like new recursive call on every.
Yes, yes.
So that's exponential. Yeah, is a bit more than quadratic, but
I think that would be like n number of into 2 raised to power m is like number of stars we have.
mm-hmm.
I think that would be our time and space. Okay.
Okay, good. Yeah. Yeah,
Switch.
pretty good solution. Yeah, we can probably swap roles.
Yep.
Let's see what we have here. Okay, 3 binary trees. Given a root of binary search tree and the number num, implement an efficient function, find largest smaller key. That finds the largest key in the tree that is smaller than num. Largest but smaller. It's like, to me it sounds like larger but smaller. So it's like the preceding element in a like sorted array of elements. So for example, let's see what assume that all keys are non-negative, okay, and return -1 if, okay, in which case we return -1 if there is no such number, and smaller, so if num is the smallest number, then there shouldn't be smaller than num, so then we return -1. Okay, let's see the example. They give us num 17. We should find the lowest, the largest that is lower than 17, and it's 14. Okay. Let's think about. Okay, if you're given a root of a node that we definitely should.
Like number 34, you have given the root.
Yeah. So we've given the root, and it means that we obviously should start from root. And I'm actually thinking, do we need to examine both children of a root node, or we immediately know that, for example, for 17, so root is 20, number is 17. It is not worth to look in the right children, because all right children are larger than 20, and thus they are larger than 17. But we're looking for one that is smaller, largest but smaller. Then we can like recursively iterate over not iterate but traverse nodes in the tree, and let me think. So that's the case for root node, and we know that we didn't find. We know that 17 is less than 20, and that we should go left. When we came left, we see node 9, and for 9, we actually should keep it in memory, because 9, in theory, could be the largest element that it's smaller than num. Num is 17, so we keep 9, save it in buffer. I suppose that it can be done recursively, so we can have some recursive helper function, and it will keep the current presumed result, which is 9, but we go to the right and we see 12. 12 is similarly, it's smaller than 17, but it's larger than 9. Obviously, we renew our current result to 12, and we go next to the right child. We go to right child, we see that 14, it's more than 12. We update current result, and 14 is still less than 17. We want to go to the right child, but there is no right child, and that means that it's the result that we want to find. Because if 14 had left subtree, left children, they all less than 14, and we basically found the result. So I think that sounds straightforward.
Yes.
Okay, let me then implement it. As I said, we want to have some helper function. Let me think a bit if we can avoid having a helper function. Do we need it? Because maybe we don't need helper function. Let me think. For example, if we are looking for 13, so from 12 we go right from 12 to 14, but 14 is bigger than 13. Then we want to go to the left children of 14. We don't have it, and that means that the previous like node of 12 is actual result. So we don't want to go back, so we need to. I think that in helper function we should remember the previous result. So let me how I see this helper function. It's like find smaller key helper. I don't know what to say, and there should be a node, and there should be current, and like we call it with root and -1 as a initial current result. I think that's how we start our traverse. Okay, let me think. So there are, I don't know, are all these elements are unique or not? There is no such condition, yeah, that we can have like same various elements or not?
I think in binary search tree we cannot have same elements.
Let's assume for a time that we don't have same elements. You know, maybe we can think about it after to see how code will become more complex with equals. But let's pretend that all unique. Okay, so there are basically two cases. No, we need to num, like I'm going to pass num anyway, of course. I'm sorry, that's num. That would be the first element, first parameter. Okay. And the node again. Node we. Now I will check, nullability inside the nullability of children references inside this helper function. So we know that node is not null when we come here. There are like two cases. If just going as an example, if node is node value, node key. If node key is larger than our num number, that means we should go to left subtree. At least we'll try to do it, because if there is no left subtree, then we go to left subtree, else go to right subtree. But before we can go to left subtree, we should check if, because if node left is null, node left, if there is no left subtree, for example, like in, for example, there is no subtree to the 9, then it means that, the best element we found is like current, so we already return current. But anyway, if it's not, we can go find the smaller largest smaller key helper, num, node left, and same current. So there it is, the case for going from 12, from 20 to 9, from 20 to 9 we go to that. Now that's another case. Let's see again. First of all, we found that there is some key that is smaller than num. Then at least we can say I don't know, new current, which is equals to node key. Okay, sort of we like saved in the buffer. We will call it with this new current if we can call, because there's always a case that node right is null. Then let me think. So node right is null. It means that we can't go further, and should basically return. We should basically return new current. But if we can go right, then we should try doing it with like node right and new current. I think that I'm missing something here. Let me think a bit more about it. Do we need to compare new current and current? I'm thinking if there is such case that new current is not shouldn't be new current. Let me think. So for example, I don't know, we're looking for 13 and 12 is less. We previously had 9, now we have 12. Okay, we go to the from 12 we go to 14, but we're looking for 13, but it's already this case, like keys greater than num. We're looking for left node, we don't have it, we return current, which is like 12, which is no, we happened here. Okay, to me it well, looks like a solution. I would, in normal situation, I would run code to see if it works, but you know, on interview you should double check everything and yeah, make it work. Ideally, make it work from first run, but that's not how we like usually work on a regular task. But yeah, in interview.
Yeah.
Anyway, let me try to run this code. Let me try. Let's see what would happen. The largest smaller number is 17. No, it's.
Yeah, actually I changed the test case.
Ah,
I had 17, but I'll get your code, and I saw that you haven't considered if number is equal to if number is
yeah. I didn't. Yeah, let's run the original, and after that, we'll think about like equality, because with equality it may be even. Okay, 14, and for example, if 13, then it should be 12. If 10, it should be 9. if 4, it should be minus 1. Okay, and after that, yeah, you're saying that about equality. That's good case. We should, yeah, look for it. Aha, you see operation timed out. So I like.
No. So that's a issue with the server of Pram.
Yeah, probably because it's hard to imagine any like infinite
Yes, that is correct.
loops here. But let's think about equals. That's actually interesting. For example, let's seek for 12, and ideally it should return 9. But in my case, it will return 12 as well. Yeah. What if we modify condition? Modify. Let me think. Okay. So we need third case here, I believe. We need like if node key larger than num, then we should consider if node key equals to num. But let me think what would be the case. So for example, we're looking for 12 and we hit the same 12. Does it mean that... no, but in the case we need 12, we actually need to return 11, right? But there are several cases, right? So the simplest case that we like know, there is a left subtree, and we need to, and again in this left subtree, let me think. We need again to find the largest smaller key, and largest smaller when the current is still previous value, like 9, not left. But the problem is, let me think, the problem is that if we don't have left subtree, then again we should report previous value as a result. So it looks like this case is totally included into the, so it should do the same as this one. So if I just probably add greater or equals, let's remove this one. Let's see. 11. Oh, nice. If I ask for 11, because if I ask for 11, it should return 9. If I ask for 20, it should return 14. Yeah, it works as we expect it to work.
Yes. Okay. So what is the time complexity of any number if you find? What will be the time complexity here?
Yeah, let me think. So it looks like in worst case we just go in the traverse tree or the height of all the tree, and I don't know if we like we consider this tree as balanced, right? So it's like
It's not balanced. Not
it's not balanced. So okay, in worst case, we just like traverse all the elements. In case there are, there is like three. Yeah, if it's not balanced, in worst case we traverse up to all the elements, so proportional to n. But I would say that in some average case, there is a log n steps by the height of the tree. That's how many jumps or comparisons we do.
Okay.
And we
Yeah.
don't
That's-
allocate much space, maybe just, I don't know, additional recursive function calls. So occupied space is, well, we just have a small overhead on these recursive calls, but if we can consider it to proportional to n space complexity or not, I'm not sure.
Okay.
But yeah,
This is okay. I think you are good there. So there is a way we can reduce the space complexity instead of recursion if we use just loop.
agree. Yeah, you're right. So yeah, we could do this. Yeah, we could do this in a loop. But
Okay, cool. I think we are good here. Yeah, it was nice connecting with you. End the session.
right, yeah, it was. Thank you for your time. It was very nice to have this session.
Okay. So you have interview lined up?
No, I don't have a interview soon. I just am practicing.
Okay.
And
I
you-
have a Google interview on Monday, so
Wow, cool. These interviews are tough. I like. I had few, but you have good chance to beat the interview.
okay. Thank you.
Thank you, Tim.
Best of luck for the upcoming interviews. Okay.
Have a nice day. Bye.